Hey guys, welcome to Theoria. Today we're going to learn everything you need to know about vectors for your first physics mechanics class. So what is a vector? When we are studying objects in the real world, sometimes just a number isn't enough. We also care about the direction. An example is velocity. So if you're trying to drive somewhere, you don't care just about how fast you're going, but also where you're going, right? Quantity is just represented by a number, they're just called scalars. A vector quantity is something that has both a magnitude and direction. So they're commonly represented by an arrow. That's kind of the image you can have in mind. So we denote a vector by a letter with an arrow of it over it. The magnitude of a vector is its length. So it'd be the length of this arrow right here. The way we denote it is by lines around the vector, like an absolute value, or we would just write the letter representing the vector without the arrow on top, because it's a number now when we are writing just the magnitude. How do we do algebra with vectors? How do we add, multiply them? That is what we're going to talk about in the next few slides. So we know how to add and multiply scalars. But to get started, kind of thinking about how we would add vectors, let's take one of the most fundamental examples of a vector, the displacement vector. To define the displacement vector, you first set up some coordinate system by defining an origin, some 0 point, and then defining your x and y axes, like the one we defined just on this page. The displacement vector is a vector that points from the starting position to the ending position of some object you're tracking. So it looked like our ball up here went from the origin and then to where it stopped, and then we drew a vector. That's our displacement vector. Now if our ball moved again, we see we have two displacement vectors now. One in the first black one and then the second red one. So now this can kind of give us an idea about how we add vectors. If we wanted the full displacement, then we would want a vector that starts at the very beginning starting position all the way to the last position. That gives us our vector C, the blue vector, which is the displacement that results from adding A plus B. So here's another example. If we have this different vector A and this different vector B, kind of following what we did with the displacement vectors, what we're going to do is we're going to take the second vector B and put it to the head of the first vector. And then our resulting vector is going to be from the tail of the first vector to the head of the last vector that we're adding, which is in our case B. So there's our resulting vector C, and that's our answer. So I want you guys to pause, draw it out, get out a piece of paper and a pencil, and try adding together these two vectors. The answer is this vector right here, C. Let's do another more complicated example together. So now, what about subtraction? So let's say we have the same A vector minus this B vector. So what is our C vector going to look like? So it turns out that subtraction is the same as adding, except for you just flip it 180 degrees. And then you're just going to do the same thing because we know how to add vectors now. You're going to bring the second vector's tail to the head of the first vector and then draw the resulting vector from the very first tail all the way to the last head. And there we go, that's our resulting vector. So the negative of a vector is itself just flipped 180 degrees. What is then the negative of vector plus itself? It's this thing called the zero vector, because any vector added to this zero is just itself. Some more properties of addition of vectors here. We have the last one we just talked about. Any vector plus 0 is itself. And then the first two shows that a plus b is equal to b plus a. And then the second one is the associative property. Now, another thing that we can do to vectors is multiply them by a scalar. So how do we do that? If we have 2 times a, then what we're going to do is scale the vector twice. Then that's our final vector. So the next important concept that's going to be useful for calculating different things is the components of a vector. So we're going to set up a coordinate system again. Here we have our vector A in the x and y plane. We define the components as the vector's projection onto your x and y axes. So here it goes over on the x-axis, it goes 5 units, and up on the y-axis, it goes up 2 units. So our x component of the vector is 5, and our y component of the vector is 2. Another way to write a vector is to define unit vectors. So vectors of magnitude 1 and having no units, pointing in the x and y axis direction. So we usually denote the vector pointing in the x axis direction as I hat, and the vector pointing in the y direction as j hat. So then we can write our vector as 5 times I hat and 2 times j hat. Because we're saying basically to get our vector, you're going to take 5 units along the x-axis and 2 units along the y-axis. We usually just write it like this: 5 I hat plus 2 j hat. If there's a z component, which we'll talk a little bit in the next video, then the unit vector pointing down the z-axis is the k hat vector. Components give us an easy way to add vectors. So here we have 2 vectors, a and b. So to add them together, we just add their components. So we add 2 to negative 2 in the y-axis direction, and 5 plus 3 for the x-axis direction. And then we get our final vector, 8 I hat plus 0 j hat. The components also give us an easy way to find the length / magnitude. So the magnitude of A is just its x component squared plus its y component squared, all under a square root. So in our case, using the above vector, we get 5 squared plus 2 squared under a square root, so the square root of 29 is our magnitude. Similarly, we can also multiply by a scalar in an easy way using components. Here the scalar just multiplies each component. So 3a is going to be 3 times its x component and 3 times its y component to get 15 I hat plus 6 j hat. Another notation that's commonly used is just the parentheses. So instead of writing out the I hat and j hat, you'll just write 5, 2. So here's some practice to do. Again, the answers will be in the description. So given 3 vectors, I want you to graph each one and then, using their components, find these 5 things.